Okay, it's another team training for the Oklahoma Housing Needs Assessment. This one's entitled Analyzing Spatial Data, and it's actually a continuation from the geoprocessing basics video. So if you haven't viewed that one, I strongly encourage you to take a look at it because we're going to be using the same data sets and talking about some of the things that we did in that exercise. And this is part of our data processing workflow in our prototype flow chart. And really, we're getting into sort of the power of the GIS system. So let's open up ArcMap here. And what you're going to see is a map that we created last time that has 3 layers. It has an area that represents a bunch of lumber leases up in Alaska called Leases F. And then there's a layer that has streams that go through the stand of forest. And then we have the location of 4 goshawk's nests. And so last time we calculated that the value of these leases in this stand of forest was worth a little over $1.5 million. And I'm sorry, a little over $1.5 billion. And but what we don't know is that was just the gross number. We can't harvest all of that forest. We can't harvest land that's within 50 meters of a stream if there are no fish spawning, and 100 meters of a stream if there are fish spawning. And then we have to also stay 800 meters away from our goshawk's nests, right? So this is a limitation, and we need now to kind of understand how much of the leased land we actually can use, and that will be probably considerably less than our 1.5 billion. So to do that, to figure that out, we're going to use geoprocessing analysis tools, and I'm going to open up the ARC toolbox here. And the first thing we're going to do is we're going to create that 800-meter buffer around the goshawk's nest. And so we're going into the analysis tools, and it's under the overlay tray, and we're going to open the union function, okay? And so what we're going to do here, I'm sorry, we're going to use the proximity function buffer, right? I'm getting ahead of myself. We're going to do union in a minute. But we're going to use the buffer function, right? That's what we need. We need the nest F layer, and we're going to create a nest buffer layer. I'll just call nest buff here, and save that. And then we're going to use a linear unit here. We're going to use 800 meters. We want 800 meters away from each nest, and you can change your units if you want to, but we're going to use meters here. And then there's also this option for a dissolve type. And if we pull this down here, you can do none, or we can dissolve them all together, right? Or we can specify a list. But in this case, I just want them to be all in one layer, okay? I'm sorry, all in one polygon. So I'm going to hit all there. And once I have that set up, we should be good to go. I'm going to hit OK. And it's thinking about it. And there you go. And so you can see here, we've created a buffer that extends 800 meters around all the nests. And what's interesting here is if I open up the attribute table, you will see, I'm sorry, wrong attribute table of the buffer. You will see that there's only one polygon, right? Because we selected that dissolve all, it put it all into one object. All right, so with that, we've created our goshawk's layer. Now we need the buffers for the streams. And to do that, I'm going to open up the attribute table. You can see here that we have a complication here, and that is if the stream has spawning, we have to have a 100 meter buffer, and if it doesn't, we only need 50 meters, and that's that distance value there is provided in the attribute table. So we can go back to our toolbox, and we are going to select buffer again. And this time we're going to select the streams F layer. We're going to specify an output. We'll call streams buffer and save that. And then this time, instead of using a linear unit, we are going to use the field option. And then we're going to use the distance field to use that. And we're not, in this case, we are not going to dissolve it. We're just going to leave it go, and we'll hit OK here. And this may take a minute because there's a lot of streams on this image. There we go. And so if we, I'm going to close that. And if we open up the streams buffer attribute table, you'll see that it has appended these buffer distances and to each of the original IDs and assigned it to the new IDs. So you can kind of see here that we've retained the original IDs and the buffer distance, which is going to be useful to us in the next steps. All right, so moving along. So now we have our buffers, and what we have to do is we have to analyze the overlying data here. Okay, and we have the data of the nests, we have the data of the stream buffers, and we have the data of all the leases. So this is going to get a little complicated. So I'm trying to do my best here to explain the numbers to you. And so I'm going to go and open up the next version I got saved to this. And all we're going to have on this screen, once it opens up, I think, is just here's the buffers for the nests and the buffers for the streams. And what we're going to do here is we're going to make a union out of those, right? And so open up my toolbox again. And this time I actually am going to Analysis Tools, Overlay Tray, Union. And we open that up and it says, okay, input features. What do we want? Well, we want buffers of streams. And then I can keep adding them. I want buffers of nests, right? So they're both specified here. And then it says, okay, I want a name for it. We're going to call this one no cut area, right? Because these buffer areas represent the area where we can't cut trees. And then the other thing you have to specify here, and this is a little arcane, right? And right now we have an optional field to join all the attributes, and the default is all. And if you do that, right, it will have all of the object IDs, but we want to specify only the FIDs, right, for the ones that are in the union. And you do this by selecting only FID. And if you don't follow this, don't worry too much. I'm going to show you after the fact, and it should be make sense. And then we want gaps allowed checked also. So okay, let's see what happens. All right, so now we have our no cut area. I'm going to turn off the buffer area. So all we have is the no cut area. And now I'm going to right click on no cut area, open up the attribute table. And here's what you get. So every one of the new polygons has its own object ID, as is the case with all GIS data. But what's interesting here is that it has created 2 new fields where we have the object IDs that were saved from the previous layers, right, from the previous feature classes. So you can see if it has an ID from the first one, it leaves that ID listed, and then it shows a -1 for the second one, and so on and so forth, right? And so this is so here's where we have IDs and where we don't have IDs, and this is going to help us in our analysis of the feature classes. So it was important for us to select only the FIDs option, because if we had all, then it would show the FIDs for both on each side. Okay, so I'm going to close this down. Now we've got to turn on our stands F. Okay, so here's all of our leases. I'm going to change the color here of this just so you can have a little more contrast for you. There you go. And so we have now our no cut areas overlaid on our lease cut areas. And so what we want to do here is we want to do the union one more time, right? So we're going to take our toolbox and we're going to go union. And we're going to input no cut area, and we're going to input our stand F layer, and we're going to call this layer, this will be the final feature class. And then for the join attributes, this time we're going to leave all turned on, and then we're going to say okay. All righty. And so now we have a very complicated and confusing looking map. I'm going to zoom in up here where we can see where we've got buffer for the goshawk's nest, we got buffer for streams, and we have just leases here. And this is all in one attribute table now. And what you can see here is we have the different FIDs listed. Since we selected all, it created one for every one of the different objects that we were considering. And you can see here that these two here are from the goshawk's nest. They're both -1. And then these are from the two different streams. One is it has a -1 for a close-in buffer and a -1 for the 100-meter far-out buffer, right? So all of the different areas that we don't want to cut will have a -1 somewhere, and that has been carried over to our no-cut area when we dissolved it. Okay, so we took all these and we put them into this new FID no-cut area. And I know that's a little confusing, but hopefully you'll see here. What I'm going to do is I'm going to open up the properties to illustrate this. And I'm going to go to labels. I'm going to tell it to use the no-cut FID layer. I'm going to tell it to label that. Apply this here. All right. And so what you're going to see here is if an FID has a -1, that means you can cut there. And if it has a number in it, that means that it is in one of the buffer areas. And the numbers, may overlap, right? Because we have some streams that have been put into union with the goshawk nest. And so now this may be kind of hard to see. I'm going to show you how you can do it in symbology. If we go to quantities, we can go to value for that. And I'm going to go to classify here. We're going to just say all I want is 2, right? Cut and no cut, or harvestable and non-harvestable, manual. And then our break value is going to be 0 here because we want to capture all the -1s. Okay. And it's not liking that. Don't know why. Try this again. There we go. And I'm going to change the color here. So -1s are harvestable. So we're going to color that green. And the other ones are not. So we'll color that red. And, you know, intuitively, you should get this now. So I'm going to zoom out to the layer here. The areas, and then we're going to, let me turn off the labels too. So you can see areas that are colored red are not, you're not allowed to harvest. And so intuitively, you can see that includes all of the areas within the goshawk nest buffer, as well as all of the buffers for the creeks. And you can see some of the creeks are wider where we have spawning going. Okay, so lastly now we have to get our value. And so to do that, I'm going to double click on that final layer one more time. And we'll go over to our definition query and we'll go to Query Builder. And what we want to do here is we want to make all of our no-cut areas equal to -1, right? So that we just want to capture the ones that are harvestable. And we hit OK here. And so now you can see, and let me turn off the stands behind there. So now all we're displaying are the harvestable areas, which is exactly what we wanted. If we right click on the final layer and open up the attribute table, then what you can see here is that we have just 372 of our polygons. So there was over 1,200. I'm sorry, there's over 5,000 of these before we made this selection. And so lastly, what I want to do is I want to calculate the new value. And to do that, I'm just going to right click on the stand value, and I'm going to go field calculator. And I'm going to say, all right, what we need here is we need the shape area times the value per meter. Okay. And these are in millions. So I'm going to divide by a million. That should do it. Okay. And now those values should be recalculated. There they go. And if I right click on that and I go, give me my statistics, I can see that we now have a sum of 1,044 million, right? So we've lost almost $500 million worth of value due to the fact that we have to, preserve areas that we can't cut. And, as an ecologist, I think that's a good thing. And we still, get to harvest 2/3 of the area, and hopefully we're doing that in a sustainable manner as possible. But the main thing is this kind of shows you how you can use some pretty complex data to answer questions that you have, research questions that you might have. And I think this one is probably more complicated than many of the housing problems we might see, but I think we'll end up using many of the same geoprocessing tools. And let me just say that we're just getting started with the geoprocessing. I'm not going to be able to demonstrate everything to you, but there's a lot of power in the geoprocessing tools. The other thing that you can do is that we can set up a spatial model using what looks like a flow chart to automate this process if we want to do this with multiple data sets. And that's what we'll look at in the next lesson.